Hello and welcome, everyone. Thank you so much for joining us. We will start very, very soon. We'll give people just a few margin minutes to join, and then we will get started. About 2 or 3 more minutes. Okay, hello everyone. Welcome and thank you so much for joining me in this live transmission, this live presentation. My name is Ola Bini and I am the technical director for CAD, which is the Centro de Autonomía Digital, or the Digital Autonomy Center. I'm sending this or presenting this presentation from our offices in Quito, Ecuador. And the idea was that this talk was going to be for the celebration, the 25th year celebration of the undergraduate program for computation and informatics at the Universidad Politécnica Salesiana. But sadly, that didn't happen. So instead of doing that, I'm going to do the talk here, and hopefully it will be to your enjoyment. I'm going to be talking for maybe about 25 or 30 minutes, and then there will be time for questions. So if you have any questions, write them in the comments on the video, and you can write in English or in Spanish. My colleagues here at CAD are helping me to translate, so I can definitely answer questions in Spanish as well. And if the language is a problem, I'm going to be talking English because I don't really speak or understand Spanish. But after this presentation, we will publish the video with subtitles in Spanish. So if there's something that you didn't catch, or if I'm speaking too fast or something like that, you will be able to read the subtitles in the future. Hopefully we will get that out within a few days. So without any further ado, I would like to jump in. Now, before I do that, just to mention, CAD is an organization that was started in 2017. We are a nonprofit, and we work on developing digital security tools to protect everyone. We work for the protection of digital human rights, and we've been doing that over the last few years. We do that by developing software, free software, and we also give trainings and presentations and try to spread the knowledge specifically to the civil society in various ways. As I mentioned, this talk was primarily meant for the celebration at Salesiana. And I was thinking about people working as students or being students in the field of technology, and what kind of thing, what kind of message I could send them. And actually, as far as I know, the students from Salesiana are actually watching this right now. So if you're there, I send my regards to you, and I'm sorry that I couldn't be there in person with you, but please be in touch with us if you have any questions or thoughts or anything. Thank you for joining me so much. And this talk, it's called. I didn't want to put the full title on the screen because it's a long title, but I called it "The Power and Responsibility of Software Developers in the 21st Century." And what I wanted to talk about more or less is this idea that as technology gets more and more widespread and technology underlies everything we do, the field of programming and the field of technology and studying these fields give you power, because the more our world depends on the technology, the more we are in a situation where we can control that technology, and the people that can control the technology are the ones that have the power. But the main question I have is, do we also take the responsibility that comes with that power? Is it the case that we are doing the right thing for the world since we have so much power? Or are there more things we can do to take responsibility? And I've been spending almost 4 years in Ecuador observing what is happening, and we see many problems almost every single day where technology doesn't work, where systems go down, where there are bugs, where there are attacks, and all these things. And to me, this is the core question of responsibility. So, before we dive in, I just want to talk very briefly about two words: programmer versus developer. And many people use these interchangeably, and I'm guilty of doing that too. But I would like to make a distinction here. In this talk, I would like to talk about it from the perspective that a programmer is a person that knows how to write things in a programming language. So they know how to use a language. Maybe they know how to write things, they know how to use the syntax, they know how to use the libraries. But a person that is a developer is a programmer, but not only a programmer. A developer is someone that takes responsibility for the quality of the project, that it works for the users, that it does the right thing. And this is the distinction that I would like to jump into. Not every programmer is a developer. And the same thing is true for writing. Maybe you know how to write in English or in Spanish, but do you know how to write a thesis? No, maybe not. That requires much more work to be able to put together a thesis, to be able to do the research and all those things. Now, in order to tell this story, I'm also going to talk a little bit about myself and my journey, because my perspective on this, I'm 40 years old right now, and I've been a programmer for over 30 years, and my perspective and what I've learned has changed my perspective on this over the years. I'm Swedish, and I grew up there in a classic middle-class family. I dropped out of school, and then I traveled around the world, and I joined international companies, and finally I arrived here in Ecuador in 2013, and I've been here since then. And over the last 4 years, I've not been traveling. I've instead been here, and during this time period, I've been continuing being a programmer, a software developer, and I still identify as a developer more than anything. And just to take a quick look at my evolution, I've gone through many different languages. I actually started when I was 8 or 9 years old on an Apple IIc, which is one of those old machines that didn't even have a graphical user interface. I remember it being green text on black background. I remember gaming on it. I had like a Star Wars game where there were like just green lines that were the spaceships. But on that machine, I learned how to program in BASIC, and that was my first programming language. And actually, the first thing I did that I remember doing was to write one of those simple programs one of those simple games where you ask questions and get the answers and check the answers. Now, after that, I started working on C, and I learned C. I learned C++. I also learned Pascal and assembler, and all of these things were part of something called the demo scene. So what we used to do was basically to create these graphical presentations and using the graphics on the machine in many different ways. And I was maybe 10 or 11 when I started doing that, and it was very interesting. I was collaborating with people. I never really did much in Pascal, but I had to learn to use it because many of the tutorials and things were in Pascal, so I picked it up. An assembler, in those days, you had to write an assembler to get the performance you wanted from graphics. But then, a few years later, I started with Visual Basic and Delphi, and that was my first job as a programmer. This was not a paid job. Delphi I actually did as like a practice in school. And then when I was 18, I actually dropped out of school and I got a full-time programming job. And in that programming job, I learned how to use Java to deliver software. But on my spare time, I also learned Common Lisp, I learned Ruby, and that was all before I was 20 years old. And after that, I have picked up many, many more languages. Now, during that same time period, in that first job, I liked some parts of Java, but I also realized that Java was not a great language for doing things quickly, for getting things done. You had to write a lot of stuff, and you ended up in a situation where like a lot of the stuff you wrote weren't really necessary. It was more about making the compiler happy than to actually talk about the essence of the business problem. So I started joining open source projects. One of them was a project called Jata. And Jata was basically a way of doing Common Lisp on top of Java. And I was part of that, and I worked on that for several years, and I added some contributions. And I felt like this approach was really, really cool. But then at the same time, Ruby started becoming famous. And the framework Ruby on Rails had just come out, which allowed you to create web systems and web applications in a very fast way. And for my work, I really wanted that functionality. But since we were all doing Java, I couldn't do it. So I actually joined another open source project called JRuby. And when I joined JRuby, it was more of a toy, but the goal was to be able to run Ruby on top of Java. And I actually helped them and worked together with them, and I became one of the core developers. And together, we made JRuby into a system that even today is used to run thousands of big systems around the world. I was part of that project for over 10 years, and I still feel like that was one of the more valuable things that I've contributed. At some point, I don't know if it was in like 7 or 8 years ago, someone told me that apparently the Oslo's airport runs on systems built in JRuby, and I can't tell you like the how scared you get when you hear something like that. Like the code you wrote is something that is used to manage airplanes. It's a little bit crazy. I had already found out that I liked the idea of programming languages. I liked the idea of implementing them, and then I felt like, okay, maybe I would like to see what happens if I design a language. So I started working on a language called Aoki, and the idea of that language basically was to see if you can remove all the stuff that is not useful and just keep as little as possible to be as productive as possible, to get to the essence of what you want to do. So Aoki was an experimental language. It was slow, but it was very powerful, and it was very interesting. And then I started work on something called Ceph, which is a second programming language meant to see if I could take some of the ideas from Aoki, but also make them more practical. But at the same time, I had other things happening in my life, so my work on programming languages started going into the background. I would say working on programming languages is one of the important things you can do to understand technology. If you understand how a programming language works, you understand how a computer works. And if you don't have that understanding, it can sometimes be really, really hard to know what your computer is doing and why things are actually working the way they do. So if you're a student, working on compilers or learning how to use compilers is a great idea. Not only learning several different languages, but also being able to understand why they do work the way they do. So for me, that thing was something that kind of prepared me. By learning many languages early, it was something that helped me get better at programming in general and software development when I got older. At this point, I can start working in a new language, and I can be productive in a new language without really having worked in it before, because once you get to a certain point of understanding languages, you can just pick up new ones very easily, and that's a very valuable skill. As developers, you shouldn't be defined by the language you use. You shouldn't be a Java developer. You shouldn't be a C# developer. No, you should be a developer, software developer, and whatever language you need to do the work you need to do, you should be able to use that. Now, I mentioned that I joined these projects, and I've been using open source and free software for most of my life. Most of the work I've done, I've given away as free software. And I believe that free software is one of the most important programming and software development movements out there. If you're not familiar, free software is basically the fundamental idea that the software we use should not by itself be locked down and controlled. Instead, it should be available for everyone to experiment. Everyone should have the right to read the code for what they're running. Everyone should be able to change the code they're running. Everyone should be able to inspect it and know that it's doing what you think it should be doing and nothing else. So for many, many years, everything I do is free software. It's on my GitHub or my GitLab or some other GitLab, but it's out there. I give it away for everyone because for me, I believe that this is the right way for the world. Free software is practical. It means that you can download the library to do whatever you want, and you don't have to pay for it, and you can integrate it with your systems. But it's also political. The idea is that not just the US and Europe will have access to the best things. Instead, everyone should have access to it. From the perspective of security and privacy, and I haven't really talked much about it yet, but we will get into that. Free software means that there are more eyes on code, and more eyes is always better. At the end of the day, programming is complex. Software development is complex. And it would be pretty arrogant to say that, oh no, my code is so good that I don't need anyone else to look at it. So finding bugs by having more people look at it is great. Being able to collaborate with other people not only makes the code better, but it also gives you connections. It makes it possible for you to create teams around the world and to learn how to work with other people. And finally, because of these aspects, there is a less risk of security problems. Security and privacy has always been part of my life. I started, my first job had a component of security, so it's always been in the back of my head. But in 2013 was when everything changed for me, where my friend Aaron Swartz, he, in the early 2013, in January, just a few days ago was the anniversary, he killed himself because of unjust prosecution by the US government. And Aaron, he had this perspective that you should do the most important thing you can do. And you should ask yourself, if you're not doing the most important thing you can do, then why not? The idea is that all of us have different skills. All of us have different knowledge. All of us have different possibilities. So of course, it might not be the best use of my time to go to Africa and help people build houses. That would be important and it would help people. But with my background as a programmer, is that the best use of my time for helping the world? So when I started looking at the world when Aaron died and thinking about what is the most important thing I can do, I came to the conclusion that security and privacy and digital human rights are the things that are the most important to work on, that based on my skill set and my background that I could work on. So from 2013 to 2017, I worked inside of the company where I was, called todxs. We worked on many different projects on a charity free software basis. And then after I left todxs in 2017, I started CAD in order to continue working on these aspects. For me, security is basically about having the tools to be able to protect yourself. How you choose to use them is another thing. Privacy is the idea that you and no one else should be able to control how you share your information, when you share it, to whom you share it. So privacy is one of those things that is underlying many of our other rights. I firmly believe that privacy by itself is extremely important for other rights, such as the right to free elections. Because at the end of the day, if you're being surveilled in different ways, that will change how you vote, how you think about your research about candidates. So with surveillance, you're not actually free to choose. And privacy is really the avoidance of attacks, the avoidance of surveillance. So for me, with my background, privacy and digital human rights are the most important thing I can work on. And that's what I do every single day. I would like to talk a little bit about the perspective on security. I told you that security is basically a set of tools that you can choose to use. But at the same time, you have to have the skills and the knowledge to use security correctly. And that's actually not fair, because most people don't have the time or the possibility to learn how to use these tools properly. So one of the things that we need to be very careful about as developers is that we make the right choices for our users to begin with. Because most people will use an application as it is. They will never turn on more security. And it's tricky to configure them correctly. So it's easier if we, as software developers, we protect the users by making the secure choice first. And then, if the user really wants to, they can take that away. But we start with the most secure instead of the least secure. And that's something that we can do in many different aspects of our life as developers. We can choose a programming language based on what is the most secure choice. We can choose the architecture of our systems in a way that protects our users. We can choose it when we design communication and transport. We can even choose security when it comes to what features are offered. And this is not true only for security applications or privacy applications. No, these should be the fundamental principles for every single program we do. Because if we don't do that, then we are exposing our users, and that's really not fair. Now, in order to protect us, we use cryptography, and cryptography is just really math that is executable. It might sound scary, and it can be complicated to get right. There are many types of attacks and so on, so it's better to use existing libraries. And there exist many good libraries. But cryptography can't be optional, especially when it comes to transport communication. If you have a system, if you have a website, or you have a call to a web service or something like that, and that is not encrypted, that means that you are exposing your users to risk. You might say like, well, I have nothing on the website to hide, but that's not the point. Encryption and cryptography is not only about making things hard to read. It's not only about confidentiality. It's also about integrity. So if you have a website that is not encrypted, that means that an attacker could inject attack code in that connection. And the user wouldn't know, because it wouldn't come from you, but they wouldn't see the difference. So by not using encryption, you're exposing your users to attack. Now, I mentioned very briefly the word quality before, and quality is a lot of different things. But one of the most important one is that it's a usability issue. If something is not of a high quality, if it crashes, for example, that's something that makes it bad for a user. But all of these things are also problems from a security perspective. If you have bugs in your system, those bugs can be exploited to attack the users. So one of the most important things that you can do as a software developer is to adopt practices that help you improve quality. Here at CAD, for example, we believe strongly that test-driven development is a very important practice for this. Not only from the perspective of quality, but also to create and design an architecture that is easy to test. A design that is easy to test is actually a design that is easier to work with. It's a design that's easier to refactor and change when requirements change. We also believe that two heads are better than one, so pair programming is one way that we do that, because since programming is complex, it's better to have other people looking at what we're doing. And yeah, sure, you can do code review afterwards, but that takes a lot of time. there is a famous saying, which is that the bottleneck, the thing that makes it hard to do programming, is not typing speed. It's not how fast you use the keyboard. It's how fast you think about the problem, because problem solving is the problem in programming. And two people will almost always be better at solving a problem than one. This is also why we believe strongly that people from different backgrounds, we believe that diversity of life, of political background, of social class, of race, of sexual identity, gender identity, all of these things are important because they contribute to making a team stronger. Finally, pair programming and TDD are part of a bigger structure where we make everything as automated as possible. We don't want to do our tests manually. We want the computers to do stuff that is easy for the computer to do over and over again. And that's why we believe that, for example, continuous integration is important. Continuous integration is basically a way of letting the computer do the hard work and telling us if something went wrong. So we automate as much as we can. Now, it's very common to talk about software engineering and systems engineering, but there are many careers that actually have the word engineer as part of it. But are we engineers? Are we programmers engineers? Imagine that a traditional engineer might build a bridge. And if that bridge falls down, there will be an investigation. There will be research into how that happened. And if an engineer builds a bridge that falls down, they will probably face charges because it's not they probably did something that was not responsible. But then think about Windows, Microsoft Windows, and the last 30 years, where every single Tuesday of every month we get many updates to Windows because there are so many bugs in it. At this point, the famous blue screen where Windows crashes is part of our dictionary. And the idea that you can solve a problem by restarting it is something that comes from Windows. And Microsoft is a big corporation. They have many skilled people working on Windows, and even they can't get it right, and they just accept that there are going to be problems. But if someone did the same with a bridge or with a skyscraper, would we accept that? Now, I'm not saying that we should go towards the idea of being engineers, but we shouldn't fool ourselves that we are engineers either. And we should take some responsibility. We should take some input from the engineering disciplines. What can you do as a student? Well, you can take responsibility. This is the first step. Don't let someone else say, don't worry about that, someone else will handle that. If you don't know who will handle it, and you're not sure that it will be handled in a good way, you should take that responsibility. You can work on improving quality. Now, that sounds like a lot of extra work, but like I just mentioned, quality actually makes your code easier to work with. It makes it easier to change. And one of the things that we know in the world is that requirements change. What someone decided 6 months ago is not the same as the requirement will be today. So we need to be ready to accept change. And high quality code is code that can be changed easy. We have to put the user first. We have to protect them, and we have to make things right for the user. And as part of this, it is important to remember, if you're asked to do something that is not ethical, or if you're asked or ordered to do something that you think is the wrong thing, you can take the responsibility of protecting the users and say no. Software and technology is really the future, and it's really this new superpower that allows you to change the world. We used to talk about magic 500 years ago, but programming and software development is magic. And just as you see in the superhero movies, with great power comes great responsibility. And you have that responsibility. You can make the world, or you can break it. And it's what you learn, what you apply right now, what you pick up in school, what you learn as a student, what you choose to practice. Those are the things that you will take out into the world, into society. Those are the things that you can either go and just do whatever you're told to do, or you can go out and try to work for a better world where software works the way it should, where it's not so full of security holes that that anyone can break in. We want to have a world where our banks can protect our data, our personal information, where our telecom providers don't get attacked all the time. And the first step begins with you. So, thank you. I don't know if there are any questions. My friend Sarah here is telling me there are some questions. So, I don't see the word here. Can you tell me what the last word here is? The first, on the right side. What's the first sentence here?
Did you ever have the fear, or do you feel pressure for doing what you do in digital security?
I mean, so the question is if I ever have fear of having the fear of pressure of doing what I do in digital security. And as some of you might know, for the last almost 4 years, I have been accused by the Ecuadorian government of digital crimes. A lot of this, or all of it, seems to be because I'm friends with Julian Assange and I used to visit him. Now, of course, I'm innocent. I haven't done any of the things that I'm accused of doing. I'm accused of breaking into system, but all my work is based on protecting systems. It's the opposite of what I've dedicated my life to do. But the truth is, yes, we are being intimidated. As an organization, we are being intimidated. As people, we're being surveilled. And it's clear that certain governments and certain people and certain companies do not like the idea of digital human rights. But at the end of the day, to me, that only makes me more clear that this is something that I have to work on. People have to work to protect these rights, because if no one does it, if no one struggles, then the other side will just run us over. So even though there is fear, and because of my situation, of course, that is not a nice situation. But at the same time, it does make it clear for me that I don't have a choice. I have to do the right thing. Now, I'm not saying that all of you should go into my line of work and doing like free software for security and privacy, although if you want to do that, that would be fantastic. However, what I am saying is that in your day-to-day life, if you work as a programmer or a software developer, you can do things to make everyone safer in your daily job. And that's the thing that is really powerful. So depending on your acceptance or level of how comfortable you are with risk, for example, or with the government being mad at you, you can choose the level of involvement in these issues. But my core message is that all software developers have a responsibility to do right by their users. The second comment I have is just thank you, Ola Bini, excellent security speaker. It's always a pleasure to hear your points of view from Monica Vargas. Thank you so much, Monica. I appreciate it. Do we have anything else?
We have a couple of questions.
Okay.
Is it more important to study cybersecurity in software or new programming languages? This question comes from Ricardo and Charla.
Okay, so the question is whether it's more important to study cybersecurity or programming languages. And it's a hard question because both of them can be important. A lot of cybersecurity classes in Ecuador right now are very focused on the offensive side, how to do penetration testing and this kind of stuff. And I personally don't think that that's something that will help you defend people. It's a component, but understanding how systems work is much more important than understanding how to attack them. So I would say if you have to choose only between those two, having a good understanding of programming languages might be better for you in the long term because it will make you a better developer. Cybersecurity is easier to pick up if you have a good understanding. And of course, there are other subjects. For example, I would say understanding how operating systems work and how file systems work and how networks work. Those are all like general things that will help you as a developer build good software no matter what you do. But they also will help you understand cybersecurity. Okay.
Thank you very much, Ola. Very enlightening talk. Can you tell us a bit more about how
So thank you, Ivan. Ivan is wondering how cybersecurity and languages are related, even though they are different. And I think I covered this a little bit in the first one. Basically, at the end of the day, you need to have a fundamental understanding of this technology that you're using in order to protect them. If you don't know, for example, how C manages memory, you might not understand why memory-safe languages like Golang are so important because of this difference. So having a deep understanding of what kind of vulnerabilities are common in what certain languages, it's easier to pick up this knowledge and understand it if you understand how the languages work. Otherwise, you will basically be learning by memorizing. Okay, C has this, Golang has this, but you don't really have the underlying understanding. So that's something that, just as I mentioned in the previous question, learning programming languages, networks, operating systems is important to be able to have a complete understanding of what can be attacked. Okay, so we have no more questions. As I mentioned, we will post this presentation with subtitles as soon as we can. Thank you so much for joining us. I'm really flattered by all the attention and by all the questions. My best wishes to all the students at Universidad, Politécnica, Salesiana, who hopefully are watching this. I'm sorry once again that I couldn't be there, but please get in touch with us and ask us any questions or any thoughts you have. And that's it. Thank you from me, Ola Bini from CAD here in Quito, Ecuador.